one of your high priority, one of your high priority requests as to additional output mechanisms. So, ladies and gentlemen, we have some unfinished business. This unfinished business relates to a model that we built yesterday that remains as yet blemished. Blemished not by the blush of youth, but by other shortcomings. So I'd like to open up a model that we built yesterday, and I'm focusing on it. It was the open population model, and was it? I'm having trouble remembering here. No, it wasn't the smoking and heart disease. Okay, so I'll go actually download it from the site because I may have placed it in a different folder here. Okay, so here we go. And we'll do it to models built in class, as built, day 3. And was it? Oh, it was the contagion model. That was it. Contagion, ladies and gentlemen. Yes, birth and immigration. Do you remember this? Okay. I want to use this in the time between now and lunch to illustrate just a couple practical things. The first thing is we have a conceptual problem with this model because we started on something we didn't finish, and I stand before you remiss for not having finished it. So do you remember that we added, pursuant to interests expressed by Megan, we added an age-specific mortality rate. Do you remember that? We talked about it this morning, the particular details of it. Yeah? Okay. Ladies and gentlemen, do you remember how we calculated age? Well, if we look at this, how did we get their age? Well, it's highlighted, right? Do you remember that? Does anyone remember that? We looked up, based on their age in years, we looked up their mortality rate. Remember that? How did we calculate age in years? Does anyone remember? Current time minus birth time. Remember that? Okay. This is an important point. How was the birth time? How did an agent know its birth time? They had a what? It's even highlighted right now. They had a, begins with a P, parameter. They have a parameter called birth time, right? Great. They had a parameter called birth time. Its default value was 0, right? Do you remember that? Okay, let's go over. So what is it that specifies for a given agent the value of their parameters? I've muttered it before. I've actually stated it, if not in a stentorian voice, in a way that was at least strong. What is it that specifies the value of a parameter for, well, I'll ask you, for main, what specifies the value of the parameter? Okay, so yeah, for a person, for an agent, it's the population. For main, what is it that specifies the value of the parameter? It's the thing that creates main. What is it? It's the experiment. Remember, different experiments, different scenarios specify different values of the parameters, right? They create main. Who is it that creates a person? Well, one thing that creates a person is the population. I heard it earlier. The population. And right that is. So for a person, for an agent, it's that population that contains it. So let's go to main, and we'll look at the population. And what we could see is that the birth time is given as 0. Is that correct? It turns out it is, because this is the initial population. And well, okay. So Tyler is probably onto something here. You're absolutely right. Maybe those people in the initial population are not all of age 0 when the model starts. Maybe they should be of different ages. Not just, why do I say age 0? I'm leaping from their birth time is 0. For everyone in the initial population, why do I say they have age 0 initially? Because the model starts at time what? 0. And so there was, the current time is 0, and they were born at time 0. They're of age 0. Right? Just out of the oven. So ladies and gentlemen, this is a little bit suspicious. It turns out there's something worse than that. But let's first remedy this, shall we not? Let's give them different ages. Can we do that? Okay, now you'll see something that I wanted you to see. Okay, go to agent. By the way, I'm going to call this version 7 of the model, just so we can distribute it accordingly. Is that okay? By the way, sometimes, you know, if you're not selecting the right thing, you can't do save as sometimes. You select the model, then you can do save as. Version 7. Okay? So I'm going to modify it. In general, if I do a chunk of work, anything that modifies the model output, I like to call it a different version. But I do it as a chunk of work. You know, I'm going to undertake a chunk of work that goes together. And then I say, that's a new version. You know, a chunk of work that changes the output. When I finish that work, I'll do it. I don't do it all along the way, version 3, 7, 8, 9, 10. You know, for every little tiny, tiny change, because there's changes that go together, that work together. So once you've done that, then you commit it to a new model version. People will recognize this from software engineering as a fundamental technique of software engineering. Yeah. Okay, ladies and gentlemen, contagion version 7. By the way, why do I do that? Why do I name it anything that would change the behavior of the model? Why do I name as a new version? It's the fundamental scientific principle of what? Reproducibility. I want to be able to run the same version of the model and get the same output, subject to things with random number seeds. It should get the same output as before. If I'm going in I call it version 7, but I'm modifying things all along the way that are changing its output, not just adding new scenarios, but modifying the model behavior in a way that will change all the existing scenarios, how can I attempt to reproduce earlier results? That model has been lost. But if I give it a new model name, like a new version, I can always enjoy recourse to. I can always go back to that earlier version of the model and reproduce results, which is desirable, particularly if you have a paper under review that show those results and you may be asked to run a few more scenarios. You want to be able to have recourse to that earlier model that created them. Yes. Okay, ladies and gentlemen, so version 7. Try to weave in principles to live by when it comes to modeling here. Sometimes I think I should be better at organizing them all. Ladies and gentlemen, okay, so we're going to add into here. Oh, I thought I said version 7. What's going on? I'm confused. Version 7. Yeah, I did say version 7. Okay, but mumble. Okay, fine. Oh no, it's exhibiting displeasure. I screwed it up somehow. Okay. Uh-oh. Okay, let's go see what's going on. That's interesting. Internal error. Wow, that's pretty cool. Okay, my hypothesis is that it's something, it got somehow screwed up because I saved it twice in version 7. I don't know why it went back to 6 here. Let's go this. Okay. Oh, look at that. Connection timed out. Oh my gosh, where is Wade when you need him? Okay, this is wild stuff. Well, fortunately, I have version 6 around. I haven't modified it. So I'm going to open version 6. Oh my gosh. Oh man, it seems like it's in a whacked out state. Sorry, I'm using technical terms here. So I'm going to close AnyLogic. Boom. Okay. So I hypothesize that it's in AnyLogic whacked out state issue. I thought it was the model version issue, but I tried to open an earlier version that I know worked, and it got whacked out still. It exhibited, it freaked out. And so I'm going to reopen it again, and I suspect it got into some weird state. I've seen that sort of thing before with the database. OK, here's version 6. Let's save it now as, forgive me, I'm going to save it as version 8. I'm not going to worry about version 7. Here we go, version 8. All fine and good. I would go and delete version 7 normally now. OK, because it was a half-baked. OK, so what are we going to do? Well, ladies and gentlemen, we're going to add a distribution of ages for the initial time. Can we do that? OK, here we go. Agent, drag in a custom distribution. Notice before I had a table function. This is a custom distribution. We actually had one before. Does anyone remember on the first day? I know the jet lag was even worse. But does anyone remember what the custom distribution was on the first day? It was between men and women. And I said I'd come back and do one that's continuous. I've lived up to my promise. OK? OK. So here we go. I'll call it initial age distribution. Boom. It's going to be a continuous distribution, and it's going to be for certain ranges. Okay. I could load it from a database, but I'm just going to do it here. So between 0 and 10, maybe I'll say, now this is a relative thing. So I'll say there's, one, a density of 1, a relative density of 1. Notice it starts to graph this out here. Between 10 and 20, I'll say there's, 1 as well, maybe 20 and 30. This is giving the density 0.998. There we go. Between 30 and 40, there's 0.997. And then between 40 and 50, there is 0.96. And then between 50 and 60, there's 0.95. 60 and 70, there's 0.9. And 70 and 100, the density, well, let's say 70 to 80, sorry. So make this 0.8. And then between 80, let's say, and 100, I'm showing it for, oh, not 1,000, 100. There's 0.5. I'm probably way overstepping the later year decline, the steepness of it. But you get something that looks like this. You notice this last category is bigger, but this is the density. It's not the total in that. It's the density, and so it works okay. It's not quite smooth, but we'll leave it for now. This is the age distribution. What this will allow us to do is to draw an age from here. These are relative numbers. You could phrase them 100 times as big. It'll be exactly the same distribution. Okay, it's going to total it up. Okay, ladies and gentlemen, age distribution. Okay, now, so we can draw an age from here. It's not going to necessarily give us 10 or 20 or 30. It's going to give us a continuous value. Just the relative density, relative density is given by this. So here's the population. The birth time, how will we get the birth time for a person? That's their initial age distribution. How will we get their birth time? If it's times 0 now, when were they born? Suppose they're 10 years old right now. It's times 0. When were they born? Year, negatives are OK. Minus 10. So now it's times 0. They'd be 10 years old, right? If they were born at year minus 10. So here's 0, start of the model. Things are going to be going on here. But if they're 10 years old, they could have been born 10 years ago. If they're 20 years old, they're born at time minus 20. If they're 100 years old, if they're a centenarian now, they're born at time 100. Why? Because 0 minus 100 is 100. It's like they're born BC or something. Yeah, okay. So minus initial age distribution. Boom. Now, to use this well, you'll notice if you do that, it says that's a custom distribution. What we actually want is this one. It returns a double. Remember in the first day, so Claire had pointed out that if you draw an option, it still says it's a double, and I said mumble. And yeah, it was a weird, probably a bug in it. But this draws from the distribution. It draws their birth time from that distribution. So if they're, and the reason we could just say minus is because it's time 0. In other words, it's the current time minus their age. It's when they were born. Okay. Great. So that's for the initial population, ladies and gentlemen. You notice we could alternatively say it's empty initially, et cetera, or loaded from a database. That's pretty nifty. And if there were a high demand, I could show it to you. Ladies and gentlemen, can we run it? What should we see? If we run this, what should we see for their distribution, for their age distribution? Well, we should see they're of different ages. So let's run this right now. We should have, if I had presence of mind, I would have run it before. We would have seen they're all of age 0. And then we would run it again, and we'd see there are different ages. I'm going to pause it here. I'm going to go down to level of a population. Here's a person born at minus 90. They're an older individual. Minus 10, minus 62, minus 4. This is a young whippersnapper. Not recommended to hire as your modeler. 21, also a bit young. 97, well, he would have wisdom beyond his years. 26, 2. Okay, 2.7. Ladies and gentlemen, we have people in the population having ages of different sorts. Okay? Are we okay with that? Okay. Next, we're going to fix a deeper malady. Ooh. Let me close other models because they're gumming up the works. One nice thing about any logic here is you can click on this. It's actually Eclipse. But right-click on that model and you say close others. Boom. Closed. Okay. Okay, so ladies and gentlemen, let's go back to the model. Okay, and I tell you there's another problem. I asked you before, for a parameter in main, what is it that sets the assumption to use for that parameter, the value to be used, and communicates it to main? What is it? What is it? It's, sorry? Experiment. It's the thing that creates main. For a person, I asked, what is it that sets the value of the parameter? And we just saw one place, right? It was the population. That creates some of the population. What part of the population does this create? It creates the initial population, okay? That creates the initial population. And that's why I could, with confidence, say minus that, because it's times 0. Actually, my software engineering side is beating me over the head right now internally because you could set any logic to not start at times 0 and mumble. Okay, yeah, it's true. I'm not going to get into that because all the models we build start at times 0. Okay, just about. Okay, but there's one other place that population is created here. Two other places. Where are they? Sorry? Immigration is one. So here, we actually add a member of the population, an immigrant. Okay? Now, the distressing thing here, the distressing realization is that we aren't specifying anything about them. So what are they going to be created with? Specifically, what's their birth time? If you go and you do autocomplete here, you'll notice there's actually two choices. This one actually would specify the birth time. The other one doesn't. The other uses the default value, ladies and gentlemen, which is what? Default value for that parameter for birth time is what? 0. So what this means is that every immigrant, no matter when they come into the model, time 0, time 10, time 20, whatever, time 35.222, they're going to have birth time of 0. So the immigrants who are coming in over time are going to be progressively more elderly immigrants. They're going to be progressively recommended by age. So ladies and gentlemen, we should really be, sorry, yeah? No, their birth time will be 0. So the value of this, because the value of this default is 0. No, because maybe they're coming in at time 10. Their birth time was 0, but now it's time 10, so they're 10 years old. But if they come in at time 20, they'll be 20 years old when they come in. If they come in at time 100, year 100, they'll be 100 years old coming in. Imagine that. Imagine that, right? So that's why I say they're, over time, we're getting an increasingly elderly population of immigrants. So that's not something we wanted to assume. So we want to assume some sort of birth time for them that's not totally unreasonable. So what I would suggest here is taking the current, so suppose we wanted them to be distributed in their age according to the initial age distribution. Suppose we say immigrants' age distribution is kind of similar to the initial population. How would we assign them a birth time suitable to be drawn from the initial age distribution? Well, so if the current time is as returned by this call to time, what would their birth time be such that their current age is given by this? Well, I'll just tell you. I'll tell you that if it's time minus this, called to this. So this is their age, and so if this is the current time, their birth time must be the current. If they're currently this age, and it's currently this time, think about it. If they're currently 40 years old, and it's the year 2000, when were they born? They were born in 1960. It's the current time minus their age. Their age is when they were born, their age in years. So it's the current time minus, okay, we have to be a bit careful though, because time in this is in what? Time is in days. Okay. So ladies and gentlemen, what do we have to do? We have to convert time to years, okay? So, okay, actually, mumble. Okay, so we have to actually divide it by year. So in other words, time is in days. We need to turn it into years. This year is going to give days per year, 365. So if the time is 365 days and year gives 365 days per year, then we get 1. It's year 1. It's 1 year in, and we're going to subtract off their initial age distribution to get the year they were born. This is giving their birth time. So in other words, we're adding them to the population, and we're specifying right now their birth time. So we're saying, hey, add an agent with this birth year, with this birth. Oh, okay, sorry. I did something bad. Thank you, Terry, for your question. So their birth time is actually in days. That's the confusing thing. Their birth time is in days. This thing is in years. So what we need is the current time minus this times year. That's what we want. That is what we want. Because the current time is in days. We need to specify their birth time in days. And if they were born 1 year ago, this age distribution is in years. We multiply it, okay, days per year. So if they're born 1 year ago, they're born 365 days ago. And if it's currently time 365, they were born at time 0. This is specifying their birth time, Terry. Now, I'm sorry, but this is the logic, in fact, because we have a difference between the units of the model and the units in which we're keeping track of their age, which is years. The units of the model are days, and so we have to deal with this bit of logic. I would love to talk about it, but lunch is beckoning, and Christine is here to help that transition, to make sure that you're fed a more nutritional mix than what I can offer you verbally. Okay, so I'm going to build this, but there's still one other problem. There's still one other problem. So all this is calculating is their birth time. So in fact, let's make it clear. Double birth time. I'm gonna call this their birth time. I'm just giving it a nice name so that my intentions are clear. So much of software engineering is making your intentions clear, ladies and gentlemen. Please, students, note my words. There we are. This is their birth time. We're adding the population at that birth time. This is the current time, and we're subtracting off how old the baby will be, how old the immigrant will be in years, and we're multiplying by years. Okay? Okay. If I were to make it even more clear, double birth age, age in years is equal to this, and then this, I'm just making my logic as clear as I can. It's age in years times, and I'll just make it even more clear. So days per year equals this. I'm making my intentions manifest, or at least that's my goal. Okay, there we go. Days per year equals that, and so this is age in years times days per year will give the number of days they've been alive. Okay. Oh, how about we make that very clear? Double age in days. Oh, that's beautiful. Look at that logic. Who can fault that? Age in days is this, and then the birth time. I'll call it birth time in days because that's what we need. Because our model is in days. I'll even put a comment there. This is called a comment. It will ignore it, but it's useful for people. The model's time unit is days. So we need the birth time in days! Exclamation point. Walks through the logic. What do you think, Jason? Is that good? Okay. Build. It's a happy camper. And soon you will be a happy camper too. Maybe you can get some of that poutine or something. Okay. Okay, ladies and gentlemen, there's still one problem with this model. You don't have to do this, but I just find it makes it more transparent. I'll put it here on the big screen if you want to see it. It just walks through the logic. Days per year is this. Oops, sorry. Here we go. So the age in years of this person, we're going to assume the age of the immigrant is the same as the initial population. That's why we say this. So we assume that the age of the immigrant is the same as for the initial population. We thus, you don't have to enter these comments. I'm just trying to give my reasoning. We thus, to determine the age of the immigrant about to be added, we therefore just draw their age in years from the initial age, the distribution from the initial age distribution. This is what it is. So we draw their age in years. Some of you might not need this logic. I'm just trying to make my thinking clear. We have days per year. That's given by this thing. This is what this job in life of this thing is. Wade intoned it in his sonorous voice. Age in days is just age in years times days per year. It follows. And then to get their birth time in days, it's just the current time, which is in days, minus age in days. Maybe I'll make that obvious. So double current time in days is equal to time this. There we go. And then the birth time in days is just this minus this. Okay. I'll make this a little bit smaller so you can see it. Mumble. Okay. So I'll put it up there. I think you go like this. What do you think, Christine? Okay. So we need the birth time in it. So I'm just putting my logic as closely. And you could see how these temporary names for things communicate my intentions. And you could see how my comments communicate my intentions. So this just shows the value of comments, or at least to me it shows the value, hopefully to my students. Yep. Yeah, I mean, that would be a better way to say it. Follows the same distribution that characterizes age in the initial population. How's that? Yeah, that's a much nicer way to put it. Thank you. By the way, this is actually a really important point, pursuant to the Kenny question. One of the best things you can do for a model, we need to really start doing it more often again, because for a while we were doing it fairly regularly, but we need to start again, is have peer reviews of models. So you have many people come together in a focused way to look at a model and comment on how to improve it, how it can do things even better. These are considered one of the foremost best practices of software engineering. And with models, it's excellent because you spot things that are less clear. You spot things that could be mistakes or could be mistakes if the code is taken to another model. You spot things that are just so confusing, it's just inviting errors. You spot things that could be done better with a pattern someone else knows. And you get feedback from many modelers on the model in a way that can improve it. And most people who build models, certainly from my group, are trained in a way that should expect them to get this sort of critique and recognize it's about improving the underlying model, how to help it do even better so they don't take it personally. It's about how can we do this even better, recognizing that it was probably put together and sometimes in a quick way, et cetera. So peer review is key. Okay, I've just put that there. This is just an example of how you can use comments and naming to make code more clear, the intentions behind that code. And I'm a big believer in that because you want it to communicate to people. Okay, But there's one final thing we have to do here. One final thing before Christine will lead us on to sustenance. Okay? The final thing we have to do is address the other place the model is created. Okay? So I noted for main, what is it that sets the value, the assumption about a parameter value and communicates it? It's the experiment. Good. It can really hurt my ear if I have to pull at it too long. For a person, what is it? And in general, an experiment, the reason it sets it is because it's the thing that creates main. And in fact, later today, after lunch, we will see experiments which run main many, many, many times. Not just once, but many times. They do so to achieve statistical reliability, to assess the robustness of the results, to recognize which patterns are merely a fluke of one particular one and which reflect underlying regularities of interest. So, in general, experiments can run one or many examples of models. And so they're responsible for setting the assumptions for a given main. A parameter in main, its value is set by the point that creates main experiment. For an agent, like person, the thing responsible for setting that value is what creates it. One place it creates it is with the population. We create a person, the initial population is created in this population object. That's why we had to set their initial age there. Another place that creates them is right here. We add them into the population with this birth time. This is their birth time in days, and it's required because it's a parameter, ladies and gentlemen. A parameter of that person is their birth time in days. It doesn't say in days, but that's what it is, because the time unit of the model is days. Okay? So ladies and gentlemen, that's one place that creates a person. Where is the other place that creates a person in this model? Birth. Ladies and gentlemen, birth. Okay? Okay, I try to make this an animated discussion. So sorry? Yeah, it gets me some exercise. You wonder why I sometimes eat a muffin. So the Sachs Institute, well, I'll tell you that story at the end, okay? It'll be worth the wait. Okay, so ladies and gentlemen, where does birth occur in this model? Does it occur in main? It occurs in person. There's the birth parameter. And that reflects the fact that birth is occurring on a per-person basis, you know, that each person has a chance of giving birth. Whereas immigration, a certain number of people per year is not necessarily tied to the particular person, despite the fear-mongering south of the border about chain migration. Okay, so ladies and gentlemen, birth here. We have birth rate, and there we add a person to the population. I told you, if you don't specify, there are two variants of add underbar population to add someone. One, where we specify the birth time, and one where we don't. If we don't specify the birth time for that person being born, the baby being born, what's its birth time going to be? 0. It's going to be default, which is, if you look, it's 0. So do we want at birth the baby that's born to have a birth time of 0? Okay, so if its age, it's suppose time has progressed onward to time 20, time 30, time 20, time 30, time 40. What should the birth time of the baby be? If we're giving birth to it right now, it should be the current time. So it's being born right now, right? So it's whatever the value of the time is. And fortunately, that's time in years. And you could think, this is actually completely compatible with that other formula we had for immigration. It's as if the baby is coming into the world with an age of 0. And so it's the time minus the age in years, which is 0, times days per year. So 0 times days per year, 0. And so it's just the current time. So the baby is born at the current time. The baby, the baby is born at the current time, i.e. right now. Okay? And ladies and gentlemen, we have fixed the flaws in this model. Now we have babies being born at the current time, and therefore they start age at the tender age of 0. And people in the initial population have different ages, and people who immigrate have ages drawn from an age distribution that follows the initial age distribution. And ladies and gentlemen, the model is finished, the model is fixed, and lunch will soon be fixed. Okay? But I did promise you the story. So the Sachs Institute has kindly sponsored me for many boot camps in Sydney, Australia, and I've been honored to be able to go deliver them. But one time we accompanied that with a talk at Sydney University in this wonderful hall. Wonderful hall adorned with evocative romantic murals celebrating the history of Australia, and remarking that Australia is just like England, except it's under the Southern Cross. And they hired a photographer to come photograph me. And so he was stationed. They had me up on a podium. Imagine that. Oh, man. You think this is bad for you. Imagine that. So I was up in this podium, and they had the photographer down, sort of going up at me. And so I was delivering a lecture. It was about an hour long, something like that. It was on integration of big data and these sort of models, et cetera. Talked quite a bit about our Ethica system for smartphone data collection, as well as integration with the models. And the photographer was trying to snapping away, going at different angles. I noticed him going around during the question and answer. But apparently after the talk, he remarked, he said, "I can't get him. He's too dynamic." He said, "He must have jumped like 3 times within 4 minutes," or something like that. He was trying to get me. He was trying to get these action shots where I would, leap in the air or something like that. But I guess he was frustrated because I was just moving around so much. He would come and try to, and then I'd be off, in some other direction. Hopefully this camera will do a somewhat better job in capturing my frenzied perambulations and my meanderings. Thank you very much. And now, ladies and gentlemen, you're well rewarded with lunch. Oh, and I will post this version of the model with all my comments and intention revealing names to the site immediately. I'm going to put it into day 3 as well as day 4, just so it's all in one place for you if you grab its version from yesterday. It is version 8, as befits the changes. Thank you very much.